Thanks so much for joining me. Well, 2026 becoming yet another very active wildfire season in Canada, sort of following a recent trend with about 5 out of the last 6 seasons where this has been the case. As of late July, numerous fires burning throughout the Boreal as well as central and southern British Columbia, now approaching 4 million hectares burned, which is well above normal for the time of the year. Of course, wildfire, a heavily politicized topic, and I've been receiving comments sort of from both sides of the spectrum on my recent videos. This one from Kenny: "It could rain every day, but they won't charge the people who are setting them. Arson is real. Wake up, sheep. It's all part of the narrative." On the other side, Sean Dalton says, "I thought you said you were going to tell us what's causing all this. I guess you don't want to lose any viewers if you tell them the truth about climate change, huh? I thought the US was bad, but I can see it's probably the same in Canada. Denial ain't just a river in Egypt." Well, stick around, folks. I've got something to say to both of these perspectives. So let's start with the first question. How many wildfires in Canada are caused by arson? And actually, we should determine what human-caused really means. It may seem obvious, but many folks actually conflate human-caused with arson. Now, arson carries a very specific definition. It's a wildfire that's intentionally set in a place where there should not be a fire. The data actually suggests that they don't occur at quite the rate that's being suggested by some. Most of our human-caused fires are actually accidental in nature, and the cause usually recreational, could be residential, could be agriculture, could be the power line industry, could just be general human carelessness. So we'll actually break down some of those figures as we move through this presentation, but it's important to get that part out of the way. So let's take a look at the actual numbers here based on the 1980 to 2024 timeframe. About 55% of all fires in Canada were caused by humans, with the remaining 45% caused by lightning. But actually, those lightning fires accounted for 92% of the area burned. It's actually the case that a very small percentage of our overall fires are responsible for most of the area burned. It's like 3% of fires account for 97% of area burned in Canada. And that stat from Fire Regime Changes in Canada, an update, a recent paper here by Haynes et al. Another interesting fact about lightning versus human-caused fires in Canada is that the majority of our human-caused fires tend to occur during the springtime. As we get into summer thunderstorm season, the majority of ignitions tend to become, they're lightning-caused fires as we get into the summer. Part of the reason for that is in the spring, lightning's not as common, and as soon as that snow melts, especially in some jurisdictions like Alberta, the fuels are, there's dead vegetation on the forest floor from the previous season, and they're ready to burn as soon as the snow melts. So we tend to see more fires caused by humans than by lightning. So in the spring, the smoke you're smelling may be from human-caused fires, but in the summer, often the case that these are lightning-caused fires that are growing to tremendous sizes on the landscape. And this figure here from a paper by Coogan et al., Seasonality and Trends in Human and Lightning-Caused Wildfires Above 2 Hectares in Canada from 1959 to 2018. Now, the government of Canada actually makes some wildfire data publicly available, and you can actually go on the website, download the data set, and run it through some Python code and visualize that data here. So Canada, area burned by cause between 1990 and 2019. We can see, again, about 88% of all area burned in Canada from lightning fires for reasons we've already discussed. Confirmed human-caused fires, 7.3%, and unspecified. Those are, I guess, fires that we didn't come to a conclusion about a confirmed cause of those fires. Again, accounting for about 4.8% of area burned during that time frame. It does vary by jurisdiction and by the year, but our sort of larger provinces, western provinces, our territories tend to see, again, that area burned really dominated by lightning-caused fires. Farther east, the maritime provinces, New Brunswick, Nova Scotia, PEI, smaller jurisdictions, moister forests, smaller area burned overall, largely dominated by human-caused wildfires in those areas. Now, the government of Alberta also making their wildfire data publicly available. This data set from 2006 to 2025 actually breaks down the wildfires by specific cause, so we can actually get a sense for what's really going on out there. Lightning-caused fires account for 35%. Recreation, again, we spoke of earlier, that could include like hot exhaust and tall dead grass, sparks from a quad, escaped campfires, you name it. So again, recreational fires at 21.1%, resident 16.7%. There we have it. Incendiary, including arson, that's 8.7%. That's actually a fairly concerningly large number overall, even though it's not the majority by a long shot. That's still a fairly large number. And actually, Alberta is known as to be a jurisdiction where arson fires occur at higher frequency. Power line industry at 5.5%. Undetermined agricultural industry, forest industry, oil and gas, you name it, at smaller proportion there. But again, this just really kind of paints a picture here for what's going on out there. There are certainly some arson fires, but they don't account for the majority, and they certainly don't count for the majority of area burned. Lightning does. Here in Alberta, 71.3% of area burned caused by lightning fires. Under investigation, undetermined does account for a fairly large fraction of that area burned. With incendiary there, confirmed incendiary, including arson, at 3.2% of area burned. So again, you're probably not smelling smoke from arson fires. It's possible you could be, but these fires tend to stay small because they happen near communities where they're high priority and they get put out fairly quickly. So while arson fires do certainly occur and they are a problem, they certainly don't occur at the rate that many people suggest. But regardless, of the human cause, whether they're accidental or intentionally set, all human-caused fires are preventable. So we need to get that number down to 0. Not sure that we will, but here's hoping. Now let's move over to the other side of this discussion and ask the question, how many wildfires in Canada are caused by climate change? Spoiler alert, not a single wildfire in Canada is caused by climate change. Say it with me. Not a single wildfire in Canada is caused by climate change. Climate change doesn't cause fires anywhere. Humans or lightning cause fires. What climate change does is actually stack the odds in favor of certain weather outcomes that make fires more frequent, more severe. We'll talk about how climate change influences wildfire seasons in Canada, but they never cause any individual wildfire. So I'm glad we got that out of the way. It's important how we use language. Now, human-caused climate change is real, and it's having a real impact on our wildfire seasons, among other things, in Canada and around the world. If the notion of human-caused climate change makes you bristle, you just have to ask yourself. A lot of climate skeptics think that humans can also control the day-to-day large-scale weather. If you think that you can control the day-to-day large-scale weather, but not the climate, over long periods of time, you have to ask yourself, why do you think that? The climate is basically just the long-term average of weather. So that's certainly not possible. By the way, we can't control the large-scale day-to-day weather, but climate change is occurring and humans are causing it here based on IPCC AR6 summary for policymakers. Human activities, principally through emissions of greenhouse gases, have unequivocally caused global warming, with global surface temperatures reaching 1.1 basically since 1850. So again, yes, climate does change naturally over time, but according to the solar cycles right now, we should actually be, we should be sort of level or even cooling off slightly, but we've been seeing rapid warming in recent years. That's the result of, obviously, primarily the emission of greenhouse gases. These are heat-trapping gases. We can see CO2 emissions really starting to pick up there after 1950. And it's starting to slowly level off in recent years, but still continuing to increase. I think the leveling off is the result of many places starting to really embrace renewables. And if we actually take a look at our surface temperatures here again from 1850, we can see there wasn't much warming initially. It started to warm up there early in the 20th century. We saw some cooling, and then it really started to rapidly pick up there after about the late 70s or so. And actually, this is kind of interesting. You can see as sulfur dioxide was scrubbed from emissions, this is a precursor for sulfate aerosols. These aerosols can actually reflect the sun's energy back out to space. It tends to cool the planet. As we remove that to improve air pollution or reduce air pollution, we actually unmask a lot more of the background warming. So we've been seeing, as we clean up air pollution, we're actually causing more and more rapid warming. So this is playing a significant role in wildfire season in Canada. And like I say, Canada's warming at twice the rate of the global average. So that 1.1 to 1.4 degree figure is the global average, but Canada, the land masses here are generally warming at about 2 times that rate and even closer to 3 times that rate in the Arctic. This has real ramifications for wildfire season. This graphic's actually showing an increase in these annual fire weather extremes. And that basically is just those hot, dry, windy weather conditions that are really conducive to rapid fire spread like that we saw on July 13th in northwestern Ontario. As we see these fire weather extremes increasing, we'll tend to see area burned increasing as well. And this figure was from this paper, Drivers and Impacts of the Record-Breaking 2023 Wildfire Season in Canada by Jane et al. Now, wildfire seasons in Canada can also be driven by what we call interannual climate variability. And that's often tied to sea surface temperature patterns around the planet. This is the current sea surface temperature anomaly map here, showing that really strong El Nino developing here in the central and eastern tropical Pacific Ocean. This can play a role in patterns of fire around the world. When we see, El Nino or La Nina, sometimes a little bit hard to kind of disentangle the relative effects of that on the atmosphere, but we know it certainly plays a role from year to year. But it's those sort of more decadal scale drivers that can also influence patterns of wildfire in Canada. And what we're seeing here, for instance, in the North Pacific, look at that, just really extreme warmth there in the north central Pacific Ocean there, with cooler than normal sea surface temperatures farther to the east. This is fairly classic representation of the negative phase of the Pacific decadal oscillation. Research in the past suggests that the negative phase is associated with greater area burned in British Columbia and less area burned across the country. But with the opposite phase, when it's cooler in this region and warmer close to the coast of North America, being the positive phase of the Pacific decadal oscillation, you'd tend to see less area burned in BC and more east of the Rockies across Canada. But in recent years, we've been sort of seeing, this expression changing, and it's not holding true anymore, where the negative PDO here, which has been ongoing for at least, 6 years since about 2020, we've been seeing area burned increasing across the country. So again, that might be a sign of that human-caused climate change playing a role in the expression of these long-term climate drivers. And again, increasing drought across the landscape here in Canada. Percent area really increased there since about late 2020 there. And again, probably correlated somewhat to this negative PDO pattern. But drought is certainly not necessary to have excessive area burned across the country. This really now infamous satellite imagery in northwestern Ontario is a prime example of what we can see with this extreme fire weather conditions when drought isn't necessary. All you have to have is a prolonged period of hot conditions, hot and dry weather that helps dry out that forest vegetation, making it flammable. And then you just need ignitions, which we had. We had several lightning strikes through the region from late June through early July. And then they all blew up at once on July 13th with that extreme fire weather event, record-breaking heat and strong winds together. They all exploded all together. It looked like they all started at once, but in fact, many of them were already burning. They just all exploded at once as a result of those extreme fire weather conditions. And lo and behold, there very little, if any, drought across the affected regions there. As of late June, the Canadian Drought Monitor is showing no drought there. So again, you don't need to have that long-term drought. When you do have it, it can make fires burn more deeply, more intensely, but certainly not necessary to have. Of course, BC also having an active fire season, but they are dealing with drought out there. Another good example, though, back in 2023, a lot of folks remember this one. This is a very impressive satellite imagery from early June in Quebec here. A number of lightning-caused fires all took off at once, again, driven by the day-to-day weather conditions. And also not any drought on the landscape as of late May. Just a few days earlier, the North American Drought Monitor map coming out here showing no drought there. So drought plays a role to some extent, but it doesn't. You don't need to have drought to have extreme fire weather conditions that have been driving many of these events in recent years. We think of communities that have been wiped off the map. Collins First Nation in northwestern Ontario this year, Jasper 2024, Lytton 2021, Fort McMurray 2016. The list goes on, and it will continue in future years if we don't make some significant changes. And even then, it's going to be hard to stop these fires with conditions like that. Now, the frequency and severity of all wildfires in Canada are really determined by those three main ingredients: weather or climate conditions, ignitions, people, and lightning, and vegetation. That's basically the fuel that's involved in these wildfires. So again, as we see increasing instances of these sort of extreme fire weather conditions, and we have ignitions across the landscape, we're going to continue seeing the worsening of wildfire seasons across Canada. So again, at that point, it becomes important to discuss the way forward and what we might be looking at in the future. Actually, a very interesting trend here is we can see the total number of wildfires over time, especially here since the early 80s, is actually declining. And that's actually a pretty good sign. That's a sign that people are probably becoming smarter about accidentally starting wildfires. But really since the late 50s and here since the early 80s for sure, we've been seeing a gradual increase in area burned in Canada, and especially in recent years with these very active fire seasons just getting worse. And again, it's the day-to-day weather that really drives these fire events. You get the really large spread, these unstoppable wildfires through the boreal forest region when you have these extreme fire weather conditions, and we expect more and more of that with a warming climate. Climate change, we're being told from fire scientists, affects wildfire season in several ways. It lengthens the fire season. You get earlier snowmelt in the spring. It can increase the atmospheric thirst or the evaporative demand in a warmer atmosphere. You basically can suck more moisture out of that vegetation, making forest fuels more flammable. And again, you're going to see more of these extreme weather events, including heat waves and droughts and whatnot, things that can make these extreme fire spread events more likely. And again, this plays a significant role in all those communities that I was talking about that were burned over. That plays a significant role in those type of things. So we need to be recognizing these events in advance. And again, more funding can help. You can't do more with less. I mean, we're going to be, it would be certainly helpful to see improvements to our ability to, monitor and detect these fires as well as to respond to them. But what is realistic? Like a lot of folks, after the July 13th event, the smoke blowing down into the northeastern United States, and U.S. politicians admonishing Canada for not doing enough to manage their forests, we have to get a realistic sense of what's possible and what scale of the boreal forest and the forests of Canada we're talking about here. I mean, there's 361 million hectares of forest in Canada. 136 million hectares of that, basically the size of 2 Albertas, is not managed. We can see that's primarily sort of the northern boreal, very remote areas, the sort of the Taiga Plain, the Hudson Plain, whatnot. Large areas of the forest aren't even managed. So, I mean, what are we suggesting here? Go out and prescribe burn or log the entire forest? It's just simply not economically or logistically feasible, nor is it ecologically desirable to do that. But there are things that we can do, and we should be focusing our efforts on sort of protecting our communities, making them more resilient to fire. So, I propose, and other, fire scientists propose, creating sort of a buffer zone around our forest communities, our wildland-urban interface across the country, as we accept this emerging reality of worsening fire seasons in Canada. We need to be thinking about, that's where we should be focusing our forest management efforts, our logging, our fuel thinning, our prescribed burning, and basically building a buffer around these communities. And the communities themselves can do fire smart. They can try to, again, remove fuels from, being right next to your home and whatnot to reduce or limit the chances of these destructive fires raising whole communities. So this is likely a better sort of use of our resources going forward and limiting these types of events, because it's just simply, again, not feasible to manage the entire forest. And again, the sort of the traditional fire regime here throughout the boreal forest is it consists of semi-regular, high-intensity, stand-renewing wildfires. These forests burn like stink when they get going. Even if you had the resources to throw at them, your fire suppression efforts would be very ineffective when fires are burning like that. So we have to learn sort of to live with this new reality, even as we go about working to curb the effects of climate change. But again, really focusing on fire prevention. We got to really focus on the things that we can control in the near term, adapting. And that also means accepting the reality that we're going to be seeing more wildfire smoke events. So again, that comes down to, ventilation, filtration systems, ensuring our communities are having clean air centers. We have masks, as unpopular as they may be, available to most folks, given the reality that we're going to be seeing more and more of these smoke events. Smoke is never good for us, so we have to be adapting to that reality as well. So, it's a very heavy topic. It can be very politicized, but I think we can keep a cool head and discuss it and discuss the facts again, that most fires are not caused by arson in Canada. That's a reality as well. Climate change doesn't cause any wildfires, but as we can see, it significantly worsens wildfire season, and it makes it sort of inevitable that we're going to be dealing with more of this in the future. If you stuck around with me to the end of this video, congratulations. Thank you so much. Thanks so much for joining me. We'll talk to you next time.